Hi everyone, I'm Yuehan. Here are my group members Shangguan and Linjiang. Our group project is Advanced Sentiment Analysis. The motivation for this project is that sentiment analysis is extremely useful to allow us to gain an overview of the wider public opinion behind certain topics. Besides, the application of sentiment analysis are broad and powerful. For example, the Obama administration used sentiment analysis to estimate public opinion to policy announcements and campaign messages ahead of 2012 presidential election. It is also the essential part of your market research and customer service approach. Not only you can see what people think of your own products and services, but also you can see what they think about your competitors. In reality, most of times we do not have enough label data to do classification, like distinguish positive and negative sentiment, which leads to no prediction accuracy. This is our project system overview. On the purple part, we do pre-processing on Amazon reviews dataset, followed by feature extraction. After that, we build classifiers using logistic regression, fast text, and universal sentence encoder. We make predictions on test dataset to evaluate each classifier. On the blue part, we input 200 manually labeled Trump's tweets data to the combination of our pre-trained universal sentence encoder model and transform learning, which will generate a new universal sentence encoder model with tuned parameters. Then we make prediction on unlabeled Trump's tweets to evaluate this new model. The dataset we used is Amazon reviews for sentiment analysis. The dataset consists of a few million Amazon customer reviews as input text and star ratings as output labels. The dimension of training dataset is 2.6 million rows and 2 columns, and the dimension of test dataset is 400,000 rows and 2 columns. We use 1 to represent negative reviews and 2 to represent positive reviews. After exploring this text dataset, we found that it does not only contain English words, but some Spanish words as well. What's worse, it also contains some punctuations without any text, so we need to get rid of those kind of data. Here is our interesting finding. We count words separately by positive and negative reviews and show words count distribution. We found that people tend to see more words in negative reviews. Next, we apply 3 methods to do sentiment analysis. Firstly, we use the traditional way that we did in the third homework, use TF-IDF to extract features. We use Rick's tokenization to break text into individual words based on regular expression. Then we remove stop words from the input because those words appear frequently but do not carry as much meaning. For each bag of words, we use hashing TF to hash them into feature vectors, then use IDF to rescale them. Next, we pass those feature vectors to build a logistic regression classifier.
Secondly, we use fast test from GSM. It's an unsupervised learning algorithm developed by Facebook in 2016. The method is character level based, so we need to tokenize into individual words and then limitize the words into characters in the processing part. Then we create a n-gram character embedding vector. It is actually an extension of word2vec. Word2vec puts individual word to CNN, and fast text breaks words into several n-grams to CNN, and the model is in the fast text is convolutional neural network long short-term memory networks. And here are some examples of our predicted scores of Amazon reviews. We can see that the scores are pretty accurate. The green one is the positive one, and white one is more natural, and the third one is negative one. And here are some interesting examples. These two examples are wrong predicted. We found that actually some ground truths are wrong, like the first one, and our prediction is actually pretty accurate. So in some cases, our algorithm can do better than human labeling. And the second one is a real wrong prediction, and we found that it has some words indicating unsatisfied attitude, although it shows a positive attitude overall. Same situations for sarcasm, which is really hard to predict.
Okay, so now we take a look at Universal Sentence Encoder, which is the most important method we use in our project. This is a relatively new algorithm released in March this year and gave us very impressive good performance with a minimal amount of supervised training data. The Universal Sentence Encoder encodes variable length English text into a 512-dimensional vector. Besides, it could be used for text classification, semantic similarity, and clustering. This method works so well because it models the meaning of the word sequences rather than just individual words. And then we use the Keras, Python, Spark, TensorFlow, and Google Cloud Platform to do the data visualization, data cleaning, and data analysis. And here is our model comparison result. You can see that the Universal Sentence Encoder with transfer learning has the best performance in training and testing dataset. The first two methods are using word-level embedding, while the last one is sentence-level embedding. And in real-world scenario, we don't have label data set for most time. So how do we deal with this issue? We found that transfer learning is an exciting concept where we try to leverage prior knowledge from one domain and task into a different domain and add task. The idea, just like transfer learning in ImageNet, in our case, we were interested in analyzing how present charms Twitter sentiment change over time. We manually label 200 Twitters as training data in transfer learning, and then use the trained model to predict sentiment of the rest Twitters. It works very well.
And here are some examples of the results of the transfer learning plus universal sentence encoder. And the result is based on Trump's tweets data. For this part, we do not have ground truth label, so we check the real tweets manually. We can see that the results makes a lot of sense. And we then apply the algorithm for the whole Trump Twitter dataset, around 3,000 minus the previous 200 labeled data. And this plot shows the number of his positive and negative tweets from 2017 January to 2018 August. And here we show it on monthly basis. Blue is positive and red is negative. So you can tell that Trump has more negative tweets overall. And in conclusion, Universal Sentence Encoder is a powerful algorithm for sentiment analysis. Moreover, we illustrate that applying transfer learning can be very useful and powerful when we have very limited labeled dataset. Our analysis of Trump's tweets data is to show that we can successfully predict the sentiment score on a new dataset with potential new features which do not exist in the large pre-trained dataset, like the Amazon reviews, by adding only 200 labeled new data. Therefore, transfer learning does not only provide good accuracy, but also can generate results very efficiently by using a time-consuming pre-trained model. So for future work, we can use universal sentence encoder and transfer learning on any other new dataset with limited labeled data. For example, if we want to know how does sentiment of China and US trade war in news change over time, or how does people's sentiment about gene-modified organism change in social media over time, we can definitely apply the method we mentioned in this project. Thank you.